Hello students, welcome to online orchestra classes. Today we'll discuss JEE mains paper held on 24th Jan 2023. So that you can get an idea chapter weightage, difficulty level, and based on this you can revise for next session, that is January 2024 session. Okay, so let us start. So look at the first question. First question. Here, two long straight wires P and Q carrying equal currents 10 ampere each kept parallel to each other at 5 centimeter distance. The magnitude of magnetic force experienced by 10 centimeter length of wire P is F1. If the distance between the wires is half, currents on them double, what is the force? What is the new force? So this is a very straightforward. This problem is based on the force acting per unit length of a current carrying conductor is mu naught I1 I2 by 2 pi r. Okay. So this problem is based on this. So now based on the given data, you substitute I1, I2 and r, you will get the answer, the first one. The initial force is F1, the final force is 8F1. Okay. Okay. Let us go to the next question. Next question. The next question is based on the apparent weight of a body in elevator. The apparent weight of a body in elevator. An elevator can go up or down with a uniform speed when its weight is balanced with the tension of the cable. That's statement one. The statement one. You have to find the statement is true or false. Next. Statement two. The force exerted by the floor of an elevator, basically which is nothing but a normal reaction on the foot of a person standing on it, is more than his weight when elevator goes down with increasing speed. Okay. So basically the basic diagram for this is, if there is an elevator, a man standing inside the elevator, his weight acts down. The force which is acting up is T. If it is moving up with an acceleration A, then you can write T minus mg is equal to ma. So it is moving down, then mg minus T is equal to m into A. So depending on the direction. Okay. So when elevator is moving with uniform acceleration is 0, then T is equal to mg. So T is equal to mg. That means the statement 1 is correct. The statement 1 is correct. Let us discuss the statements. The statement 1 is correct. Whereas, if you look at the statement, force exerted by the floor of an elevator on the foot of a person standing on it is more than his weight when the elevator goes down with an increasing speed. Increasing speed is nothing but acceleration down. In this case, look at this. mg is down, the normal reaction n, then mg minus n is equal to ma. So n is equal to m into g minus a. So definitely the normal reaction is less than his weight. So the apparent weight is less than the true weight. True weight is mg. So the other statement is false. So the answer is statement 1 is true, statement 2 is false. Statement 2 is false. Let us go to the third one. Look at the third one. So the third problem is based on photoelectric effect. So as you know that whenever a light of certain frequency nu incident on a photometal, the electrons are emitted with a kinetic energy half mv square. So here, if you apply the law of conservation of energy, the energy of incident photon is equal to the energy required to remove the electron from metal surface, generally we call it the work function, plus the remaining energy is half mv square. See, this is a photoelectric. Now, so this kinetic energy can be measured by applying a potential that is nothing but a stopping potential. Kinetic energy is equal to charge of the electron into stopping potential. When kinetic energy is equal to the potential energy, it stops reaching the anode and the photocurrent is zero. So based on this, 4 statements are given. What is statement 1? The stopping potential depends only on work function. Definitely the statement is false. Stopping potential depends on the frequency of incident light. Doesn't depend on work function. Work function depends on the nature of the photometal. So the saturation current increases as the intensity of incident light increases. That means if more number of photons incident, more number of photoelectrons are emitted. So the number of photoelectrons emitted is the measure of current. So this is true. Statement B is true. So third statement, the maximum kinetic energy of photoelectron depends on the intensity of incident light is wrong. Maximum kinetic energy depends on the stopping potential. Or maximum kinetic energy depends on the incident frequency. Photoelectric effect can be explained using the wave theory of light. It is also wrong. Why? Okay. Photoelectric effect supports the quantum nature of a light, that is particle nature of a light. The name of that particle is photon. Photoelectric effect is the collision between a photon and a bounded electron of photometal. So only B is correct. Okay. So you can expect a question based on photoelectric effect. So let us take the next one. So then the fourth question is based on gravitation. Variation of weight with height, gravitation. Okay. So we know that GH is equal to G into R by R plus H whole square. Variation of G with height. So this problem is based on this formula. Okay. So if you apply this formula, you'll get the answer here. The weight of a body at the surface of the Earth is 18 Newton. The weight of the body at an altitude of 3,200 kilometers above the Earth's surface. A radius of the Earth is given as 6,400 kilometers. So now by applying this formula, you can get the answer. So the answer is 8 Newton. It's a straightforward formula-based question in gravitation. So you can revise how the G depends on height, how the G depends on the depth, how the G depends on the latitude. Okay. So you can expect a question based on these concepts. Let us go to the next question. So this is, the fifth one is based on elasticity. Elasticity. Okay. So we know that Young's modulus is equal to stress by strain. Stress by strain. Delta L by L. So where delta L is called elongation, of course, here is this is nothing but a delta L. It is also a straightforward. All the values are given. All the values are given. Find elongation of the wire. So this problem is tightly based on the definition of the Young's modulus. Now look at the sixth question. Sixth question. 1 gram of a liquid is converted into vapor at the pressure 3 into 10 to the power of 5 pascals pressure. If 10% of heat supplied is used for increasing the volume by 1600 centimeter cube during the phase change, then find the increase in internal energy. So definitely we know work done is PdV. So we know that work done in the thermodynamics was PdV, which comes 480 joules. If only 10% of it is used work done, so find out the rest goes to the internal energy, which is 90% of heat. So the answer is 4320 joules. Okay. So this is based on the heat and thermodynamics concept. Look at here. Seventh one. A modulating signal is square wave as shown in figure. If the carrier wave has given as Ct is equal to 2 sine 850 volts, then the modulation index. So here, with a straightforward, the definition of modulation index is the amplitude of modulating signal by the amplitude of carrier wave is the modulation index. So the amplitude here is 1, here is 2. So the answer is 1 by 2. 1 by 2. Let us go to the eighth problem. So here is also a very standard question in Newton's laws of motion. As for given diagram, a weightless pulley P is attached on a double inclined frictionless surface, the tension in the string you have to find out. So naturally, this type of problems can be solved by applying Newton's second law. Let us say T is the tension in the string. T is the tension in the string. M1G is the M1G sine theta 1. So here the component of gravity acting down is M2G sine theta 2. So let us say the acceleration is A. Okay. So if you apply Newton's second law, M1G sine theta 1 minus T is equal to M1A. Here, what is M1? 4 kg. T is the tension in the string. Same thing if you apply for the second body, T minus M2G sine theta 2 is equal to M2A. So here, we don't want A, we want tension. So eliminate A. Eliminate A, calculate T value. That's all. You have to find that one. So you will get this answer. Eliminate A from these two equations, find out T. So this is what you can get that one. I'll look at next problem. Look at the 9th question. Given below are the two statements. The statement 1 is A, the assertion A, the other statement has reason R. So the assertion A is photodiodes are preferably operated in reverse bias condition for the light intensity measurement. The current in the forward bias is more than the current in reverse bias for a PN junction diode. So if you look at, so photodiodes are operated in the reverse bias as a fractional change in the current is due to light is more easy to detect in reverse bias. Okay. So the answer is the statement 2. Both A and R are true, but R is not the correct explanation of A. So basically the conceptual question which comes in semiconductor physics topic. Look at next one. 10th question. So it is based on the electromagnetic waves topic. If E and K represent the electric field and propagation of vectors, E is the electric field of electromagnetic wave, K is the propagation vectors of electromagnetic waves in vacuum, the magnetic field vector is given by. So here, in case of an electromagnetic wave, the direction of propagation is perpendicular to the direction of electric field, and the magnetic field is perpendicular to both of the vectors. So always these three are mutually perpendicular. The direction of propagation, direction of electric field, direction of magnetic field. All the three are mutually perpendicular. E perpendicular to B, B perpendicular to the direction of propagation. Okay. So if you apply this concept here, we know that B is equal to E by C, and velocity of light C is equal to omega by K. Okay. Omega by K, where K is propagation vector. This is the velocity of light. So if you apply, you will get B is equal to 1 by omega times K cross E. So the answer is 1. Now look at the 11th one. 11th one. In the 11th one, a circular loop of radius R carrying a current I ampere. The ratio of magnetic field at the center of a circular loop and a distance R from the center of the circular loop on its axis. So it is also a formula based. We know that the magnetic field along the axis of a circular coil, a distance x, where R is the radius, okay, is mu naught I by 2 R square plus x square whole to the power of 3 by 2. So apply this formula. So first at x is equal to 0, it is B1. When x is equal to R, it is B2. So find B1 by B2, we'll get 2 root 2. This is a very straightforward formula based question. Even board examination, you have the derivation of this, derivation for this magnetic field along the axis of a circular coil. Let us go to the next one. Look at a traveling wave described by the equation y is equal to 0.05 sine 8x minus 40, the velocity of the wave. So it's a very, very straightforward. If y is equal to a sine kx minus omega t or omega t minus kx, the velocity of sorry, the velocity of the wave, either c or v, is omega by k, because omega is 2 pi by t. What is k? 2 pi by lambda. So which is equal to lambda by t. Okay. So the velocity is equal to the product of frequency and wavelength. So you'll get the answer is 0.5 meter per second. Let us go to the next one. So here, look at the question number 13. So R1, R2, R3, R4, R5 connected to battery of voltage 24 volts and internal resistance of is 3 ohms. So we have to find the current I4, I5. Is very easy, straightforward formula. These two are parallel. These two are parallel. And we can write so R1 dash, R2 dash, R3 dash, and internal resistance R. You can find current. You can find current. So once you know the current, you can find the current flowing through each resistor. So I1 is equal to R2 by R1 plus R2 into I. If I is the current, branch current. Similarly, you can find out current, branch current I2 is equal to R1 by R1 plus R2 into I. So it's also based on the electric circuits. It is very simple. It's not so tough. So the answer is 4. This one. So look at the 14th one. Again, there are two statements. Statement 1, the Brewister's angle for the light propagating from air to glass is theta b. I think you know the Brewister's angle is when light is traveling from air to some other medium, maybe glass or water. When the incident light is unpolarized, where dot component and arrow component is there, when incident angle is Brewister's angle, the reflected light contains only dot component. That means completely plane polarized. The reflected light is completely polarized. And at this Brewister's angle, refracted light and reflected light are at 90 degrees. This is R. Okay. And tan of theta b is also equal to refractive index of second medium with respect to first medium. So based on this knowledge, this question is asked. So if Brewister's angle for the light propagating from air to glass is theta b, then the Brewster angle for the light propagating from glass to air. So if I apply this concept, so what is statement 2? The Brewster's angle for the light propagating from glass to air is the inverse one, is the refractive index of glass. If I apply this, statement 1 is true, the statement 2 is false. So the answer is 2. Look at the next one. 15th one. If two charges Q1 and Q2 separated with the distance d, placed in a medium of dielectric constant K, what will be the equivalent distance between the charges in air for the same electrostatic force? So we know that F is equal to 1 by 4 pi epsilon naught K Q1 Q2 by R square. Okay. Suppose the two charges are in different medium, to exert the same electrostatic force, what is the concept? 1 by 4 pi epsilon naught Q1 Q2 by K1 R1 square must be equal to 1 by 4 pi epsilon naught Q1 Q2 by K2 R2 square. So that means the condition for the same force is K1 R1 square must be equal to K2 R2 square. R1 is in the first medium, R2 is in second medium. If it is air, K1 is 1. Okay. So sometimes root K into R is constant. So if you apply this concept, you will get the first option. So to experience same electrostatic force, when the two charges are in different media, equate the force. Now let us look at the look at the 16th. Consider the following radioactive decay process. So take this process. Okay. So here in alpha decay, beta decay, gamma decay. So you have to understand what happened when there is alpha decay. In case of alpha decay, mass number decreased by 4 times, atomic number decreased by 2 times. That's what we can write. So the alpha decay process. 218 becomes 214, 84 becomes 83. That is the alpha decay process. You should know this concept. Similarly, for beta decay, mass number no change, but atomic number changes by 1 unit. So that's why 82 becomes 83. But in case of gamma decay, no change in mass number, no change in atomic number. Okay. So if you apply this concept, you will get the answer, third one. So just to revise once, what is alpha decay, what is beta decay, what is gamma decay. So based on that, you can expect a question. So now look at the 17th question. There are two statements are given. The temperature of gas is minus 73 degrees centigrade. When the gas is heated to 527 degrees centigrade, the root mean square speed of the molecule is doubled. That's statement 1. Statement 2. The product of pressure and volume of an ideal gas will be equal to the translational kinetic energy of the molecules. Let us check this. So we know that T1 is given, T2 is given. What is the formula for root mean square velocity? Root of 3RT by F, molecular weight. So if you apply that concept, V2 is equal to V1, the statement is true. The statement 1 is true. But if you look at the statement 2, we know that PV is equal to nRT. But the translational kinetic energy is 3 by 2 nRT. So that means statement 2 is false. So the answer is second one. Statement 1 is true, but statement 2 is false. Now let us take this 18th question. So here, the maximum vertical height to which a man can throw a ball. For example, when man projects with a vertically up, the maximum height is u square by 2g. And the maximum horizontal distance up to which he can throw the same ball. The maximum horizontal distance. Maximum means the angle of projection must be 45 degrees, u. So the range is asking range. Range is equal to u square by g sine 2 theta. Theta is 45, sine 90 is 1. So from that, you can find the answer is 272 meters. Third one. Look at the 19th question. A conducting loop of radius 10 by root 2 centimeters, radius r, is placed perpendicular to the magnetic field. The magnetic field decreasing to 0 at the rate, a steady rate, then the induced EMF in the circular loop. So this is based on the concept the EMF induced is equal to minus d phi by dt. The rate of change of magnetic flux is equal to the EMF induced. So what is the formula for flux here? Pi is equal to field into area. area is pi r square. If n turns are there, multiply by n. So d phi by dt is dB by dt into pi r square. So if you apply this form concept, you will get 10 millivolts. The induced EMF in the circular loop at this one. So I'll show the answer here. Look at this one. So write this concept you apply. Okay. Next, look at th question. So it is a match the list 1 and list 2. So Planck's constant, stopping potential, work function, momentum. So you're right. The list 2 is dimensions. So for a Planck's constant, you use E is equal to h nu. So the Planck's constant is energy by frequency. Energy by frequency. Energy is m L square t to the power of -2. The frequency is 1 by t. So using this concept, you can write the dimensional formula of Planck's constant. Stopping potential is potential, which is nothing but work done per unit charge. Charge is nothing but product of current and time. So you can use. And work function is nothing but also energy. And momentum. Product of momentum is the product of mass and velocity. So based on this, you can match. So if you match, you will get the second option. The second option. So always you can expect one question based in units and dimensions. Look at the section B. A spherical body of mass 2 kg starting from rest acquires a kinetic energy 1000 joules at the end of 5th second. The force acting on the body. The force acting on the body. So, since kinetic energy is given, we can calculate velocity. We can calculate velocity. So, from this, once you know the velocity, by using the formula V is equal to U plus AT, since T is given, U 0, because starting from rest, you can calculate A, then F is equal to MA. It is a straightforward mechanics problem. So the answer is 40. So let us go to 22nd. A block of mass 2 kg attached with two identical springs of spring constant 20 Newton per meter each. The block is placed on a frictionless surface and the ends of the springs are attached to the rigid supports here. It is K, it is K. Of course, K1, K2 is there. If the mass is displaced from its equilibrium position, it executes simple harmonic motion, the time period of oscillation. So actually here, if 2 kg is moved by x, right, the compression of the second one is equal to extension of the first one. X is same. X is same. And F is different. Because, okay, of course, in this case, K1 is equal to K2. Since when X is same, they are connected in parallel. They connect in parallel. The effective spring constant K is equal to K1 plus K2. And the springs are parallel, K1 plus K2. Then the angular frequency omega is root of K effective by M. If you apply this concept, you will get the time period, because omega is 2 pi by T. You will get time period. From that, you can calculate the X value. So the X value is 5. So look at now 23rd. 23rd question. A hole is drilled in a metal sheet at 27 degrees centigrade. The diameter of the hole is 5 centimeter. When the sheet is heated to 177 degrees centigrade, the change in the diameter is d into 10 to the power of minus 2. The value of d will be. So it's directly, this problem is based on the diameter at temperature T. It is equal to d naught into 1 plus alpha delta T. Based on this, you can apply this concept, you can find the value. Okay. Next, 24th. Now look at 24th question. In a given LCR series circuit, so the ratio of quality factor to bandwidth. So I think we know, if you look at the current versus the frequency, in if omega naught is the resonance frequency, omega 1 and omega 2 are the frequencies at which the current is. If I naught is the peak current, omega 1 and omega 2 is I naught by root 2. That is the RMS value. Then omega 2 minus omega 1 is equal to delta omega. It's called bandwidth. So omega naught by delta omega, which is nothing but Q factor, which is also equal to L omega naught by R. So if you apply that formula, you will get the bandwidth. Apply the formula, you'll get the bandwidth. And resonance frequency, already we know that 1 by root LC. So we should know this formula for the Q factor, quality factor. It is the ratio of resonance frequency to bandwidth. Bandwidth is omega 2 minus omega. Now look at 25th. 25th. A hollow cylindrical conductor has length 3.14 meter, while its inner radius and outer radius are 4 and 8. The resistance of the conductor is, okay, it is a straightforward formula. R is equal to rho into L by A, where A is pi b square minus A square, outer radius square minus inner radius. So straight away, if you apply this formula, you'll get N is equal to 2. Look at the 26th question from the ray optics. Ray optics. As shown in figure, this is the figure. The combination of thin plano-convex lens and thin plano-concave lens and plano-convex lens used to image of an object placed at infinity. The radius of curvature of both the lenses is 30 centimeter. Refractive index is same for both. Both the lenses are placed at a distance of 40 centimeters from each other. Due to the combination, the image of the object is formed at distance x. So first, find out the focal length. Find out the focal length. So f1 is minus 40 because it is a plano concave. This one. For a plano concave. The other one is plano convex. So one is focal length negative. The other one is focal length positive. So the image from L1 will be virtual on the left at a focal length of 40 centimeters. That means, look at here. Just I'll show here. When a parallel beam of light incident, it will diverge. It will diverge. All these divergent rays appear to come from the focus. So this is minus 40. So the object for L2 will be 80 centimeters from L2. So now, okay. So it is 40 and it is 40. Total 80, which is 2f, which is 2f. So the final image is formed at 2f. That is, answer is 120. 120. Now look at 27th problem. Look at a solid sphere A rotating about an axis PQ like this. The radius of the sphere is 5 centimeters, then the radius of the gyration will be root x centimeter, the value of x. So generally, I is equal to Ig plus mx square, parallax theorem. So I is mk square, mkg square plus mx square. So here is the k is the radius of gyration about the given axis, kg is the radius of gyration about its center of gravity, x is the distance between the two axes. It is x. So if you apply this concept, if you apply the parallax theorem, apply the parallax theorem, you will get x as 110 centimeter. X as 110 centimeter. Apply that. Next, 28. 28. Vectors ai cap, bj cap, 1k cap, and 2i cap minus 3j 4k cap are perpendicular to each other. And 3a plus 2b is 7. The ratio of a by b is x by 2. Then the value of x. So I think you know that when the two vectors are perpendicular, then a dot b is 0. From that, you will get 2a minus 3b is minus 4, and also given as 3a plus 2b is 7. From that, find out, solving for a and b, you will get a by b 1. So x value is 1. Now look at the 29th problem. 29th. So it is a density of the nucleus. Assuming that protons and neutrons have equal masses, mass of the nucleon is given, radius is given, the approximate ratio of nuclear density to water density is n. So we know that density definition is mass by volume. Find out. Since the density of water is 1, Based on that, you can find out the value. So the answer is 11. This is 11. So it is directly based on the density concept, mass per unit volume. So look at the 30th. A stream of positively charged particles having Q by M. Q by M is also called specific charge with velocity deflected by an electric field. E value is given. The direction is minus j cap, that is y direction. The electric field exists in the region of 10 centimeter along the x-axis, like this. Okay. And you have to find, due to electric field, the deflection of the charge particle. So y value. So here the two things. The horizontal displacement x is equal to horizontal velocity into time. And during this horizontal displacement x, the vertical displacement y, half at square. So y is equal to half. A is electric force divided by mass, because the electric field is acting along y direction. T is x by Vx whole square. So if you, this y is called deflection. So the y direction deflection is 2 mm. So this problem is based on the motion of a charge in electric field, only electric field. So if you look at this, most of the problems, of course, some around 10 questions are conceptual, and the remaining questions are based on direct formula application. Direct formula application. Okay. So if you revise the basic formulas and concepts, enough to score almost 90 above marks. 90% marks you can easily score that. So thank you. Thank you.